I audible, Miss?
Yes, please.
Morning, everyone. My name is Aderia Hanifa Ananda, NPM 219011004. And today, in this today's occasion, I would like to deliver my material, Entrepreneur Research Chapter 10, about the analyzing quantitative data. So, we're defining the quantitative data analysis first in plain English. So, quantitative data analysis is actually a method used to make sense of a numerical data in a straightforward and systematic way. So, it could be involves the use of mathematical and statistical techniques to understand and draw a conclusion from data. It consists of the three things that we can make sure. The first one is variable, the second one independent variable, and the third one is dependent variable. Okay, this is the hypothesis that we can define first. So, hypothesis is an assumption or informed guess a researchers makes about the relationship between two or more variables, and it probably refers to the extent to which your findings can be explained or not as the result of random change. And in the hypothesis, it's including a null hypothesis. It actually means that when you test the likelihood that your results occurred by chance, which is certainly worth doing, you make an assumption that there is no relationship between the variables. So it's actually null hypothesis, called a null hypothesis. So we can see in the left side, the formula the formula P equal 0.05 means one change in 20 of result occurring through change, and etc. And we can see in the picture and the meanings of the from formula itself. This is the significance where it's the key preference from the hypothesis itself. So the significant means one change in 20 or beyond that this happened by chance where the P equal 0.05 or less, where that I have explained in the picture on the left side in the previous slide before. And highly significant means one change in 100 or beyond that this happened by chance where P equal 0.01 or less. So very highly significant means one change in the 1,000 or beyond that this happened by chance where P equal 0.001 or less. This is the significance. So this is one-tiled hypothesis and two-tiled the difference one-tiled hypothesis and two-tiled hypothesis. We jump to the definition first. From the one-tiled hypothesis, a one-tiled hypothesis is a statement that specifies the direction of the expected relationship between variables or the expected outcome of an experiment. Besides that, two-tiled hypothesis is a statement that does not specify the direction of this expected relationship or outcome. It simply suggests that there will be a difference or an effect. For the symbol in one-tiled hypothesis, it's often denoted by the symbol by the symbol greater one or the less than, indicating the direction of the effect. And that between the one-tiled hypothesis, the symbol of two-tiled hypothesis, it's often denoted by the symbol not equal to. So in the inference, one-tiled hypothesis, it's specifically looking for a result in one direction or greater than or less than. So it implies that we don't care about the opposite direction. For the example, the new drug being less effective. In inference in two-tiled hypothesis, it's more general and allows for the possibility of an effect in either direction So it doesn't make a specific prediction about the which treatment will be better. And from the statistical testing sites, in the one-child hypothesis, it's when the testing, it's typically use a one-child statistical test. For the example, a one-child t-test to determine if the data supports the expected direction. Where the statistical testing in two-child hypothesis, it's typically use a two-tailed statistical test, or for the example, a two-tailed t-test to determine if there's a significant difference between groups without specifying the direction of the difference. So in the hypothesis, we can see, we can jump to the analysis roadmap. So this is the first one step that we can see. It's the first one is review your research questions. So what question do you need to answer by interpreting the data? And the next we can reviewing the data to look through the data frequency and description, and can we put possible association between variables and what seems to be there that might you expect. Then what surprise are there and what do you need to check, and we can, and the next we can create a hypothesis after reviewing the data. And jump to the step 3, we can choose the test. So the first one question might be, do you wish to test the effect of some category based variables, for the example gender, ethnicity, grade, organization, or organization type like a public or private or non-profit, organization size like larger, small, medium, or we might be question, do you wish to test the association between variables measured on a scale and see whether they vary in a consistent way or whether one variable can predict the outcome of the other. For the example, we can take the example from the manager training, management style, manager self-confidence, range of the management experience. This is the test of correlation and regression. We might be also the question, do you wish to examine whether a number of variables cluster together to represent something that you might then treat as a new variable? For the example, what are the principal components of employee engagement in your organization? It's actually principal component analysis or factor analysis. So in the assessing the relationship between two variables, when dealing with more than two variables, it's actually called multivariate analysis. And where there's no association or relationship between the variables, they are referred to as being independent. So this is what are the steps I need to take build a cross tabulation in the application SPSS. As we know, this maybe this one is the application in the old version. It's not a new ways, but uh I provide some of the steps that have a red line. So we can, in the circle line, we can see the features cross tab statistics. Okay, I think this is the last slide. Thank you so much. Is there any question?